Let's continue our unit on right triangles and similarity as we talk about similar right triangles. Special properties we get when we have an altitude splitting a right triangle into multiple triangles. We'll also take a look at some special right triangles. You'll find out why they're so special later on. Just have to wait. So let's start off with an altitude, CD, splitting this triangle ABC into multiple triangles. So right now we have triangle ABC with a right angle C. I'll draw that in there. Along with point D, so CD is perpendicular to AB, which means we have a right angle there at C angle CDB. So we want to show that triangle ACB is similar to triangle ADC, and that it's also similar to triangle CDB. So I'll highlight these. ACB. So we're going to show all these by AA similarity. And for good measure, I'll throw in a third angle to show you how they're all similar. So these are all similar by AA similarity. And here's how. So angle C in triangle ABC equals 90 degrees. We can see that by the diagram. We don't know any other angle measures, so let's call angle A X degrees. So angle A is X degrees. That would make angle B 90 minus X degrees. Because the sum of the angles in a triangle is 180, therefore there's only 90 degrees left since we have the right triangle here, and if this one's X, we have 90 minus X for the third one. Okay, hopefully that makes sense for now. So next let's take a look at triangle ADC and show that they have a right triangle, and show that it also has X and 90 minus X. So since these two are a linear pair, I've got a right angle here. So angle D in that triangle is 90 degrees. And you can see that they share angle A, which is X degrees. So I can see already by AA similarity that is true. And since this is a right angle here, if this were X degrees, that would make this 90 minus X because it's complementary. Since they both form, those two angles add up to form the right angle. So angle C in that triangle would be 90 minus X. So there we can see they have to be similar because all the angle measures are the same. Now let's look at the last triangle, triangle CDB. Got a third color for that one. Triangle CDB, that one, we see that the right angle is at angle D, and angle C for that triangle is X degrees, since we labeled that one X, since it combines to give us 90 degrees there. And then angle B is shared, so that would be 90 minus X degrees. Okay, so we can see by angle similarity that those all have to be the same. Now we'll use that now as we do some problems to find missing measurements. We just got to find, since we know this altitude splits these two triangles, actually all three of them, into similar triangles, we just got to figure out which proportion we'll use to match up the corresponding parts. Because we see that the purple to the blue one, it just rotates over. If I want to get the blue to the red one, I've got to flip that one to match up its 90-degree angle, and same with the purple one. So we've got to kind of maybe manipulate the figure and work it to see where the corresponding sides are. So we want to find X, which is this side here. I see in that triangle that I've got a hypotenuse and looks like the shorter leg. So in my blue triangle, I've got the shorter leg. I'll abbreviate that SL, and the hypotenuse. And those two are X and 4. So now I've got to find another triangle where I have the shorter leg and a hypotenuse. I'm going to use a different color so that it's easier to tell apart. So if I look at the big triangle, I've got the hypotenuse given, which is 5. So make sure when you match up your proportions, match up corresponding parts. That's why I labeled that outside here, so I know which one goes on top, which goes on bottom. And then the shorter leg would then be 3. I have 2 legs, but the shorter one is 3. So now I've got a proportion I can solve that. So x over 4 equals 3 over 5. So cross products are equal, so 5 times x is equal to 3 times 4. Divide both sides by 5, x equals 12 over 5, or 2 and 2/5, or 2.4, whichever you prefer. Okay, let's try number 2 here. So I've got x, and if I'm looking at the small triangle, I've got 2 sides, so I've got x and 5. X, as I'm looking at it, is the longer leg. I'll abbreviate that LL. And 5 is the hypotenuse. So I've got to find another triangle where I have the longer leg and the hypotenuse. So if I look at this one in purple, notice I've got the hypotenuse and I've got the shorter leg. So that's not going to help me. So I need to look at the other triangle. The other triangle is the big one. And in that one, I've got all 3 measurements. So that'll work. Just got to pick out which one I need. So long leg, 5 or 12. 12 is longer than 5. Hypotenuse is 13. So now once I have that, I'll just solve my proportion. Cross products are equal, so 13 times x equals 12 times 5, which is 60. Divide both sides by 13, and I get x equal to 60 over 13. 13 goes into 60, got to think now. 4 times 13 times 4 is 52, which means I have remainder 8. So 4 and 8/13 will be the length of x. And that seems to make sense because 4 and 8/13 is less than 5. 5 is the longest side in that smaller red triangle. Okay, so you got to use a little bit of visual reasoning to figure out which side we need to find. So why don't you try this next one on your own. Pause the video and restart it when you're ready. Alright, so I found the triangle I needed to find was y. It was that smaller one on the left in green. So y and 3 were the 2 side lengths that I have. Y is the hypotenuse and 3 is the shorter leg of the 2 legs. And I matched it up with another triangle as the bigger triangle. 9 was the hypotenuse, y was the shorter leg. So notice I have y, both sides of my proportion. Cross products, y times y is y squared, 3 times 9 is 27. So here all I had to do is take the square root of 27, which I can simplify. Square root of 9 times square root of 3. Square root of 9 is 3, so it's 3 times the square root of 3. And when we're doing our work, we want to keep our numbers in simplest radical form because it'll make it easier to do our calculations as we start to find patterns within our triangles. Okay, so here's where you can apply what we know about similar right triangles. So read through this problem and set up the proportion and able to find out the length of W in order to find the height of the gym wall. So hopefully you figured out this is a pretty cool way to measure something indirectly. If you have this cardboard square, you can line up the top of the gym wall and the bottom. That guarantees that we have a right angle there, and if you look directly straight across, measure that length, and we can measure the length up to eye level. That's all we need in order to find the rest of the measurement, because we have 2 similar right triangles, one in black and the one in purple. So I compared long leg to short leg in both triangles to did cross products and found W equals 14.45. So since this was W, this top part, we need to then add it to 5 to get the total height. Total height would be 19.45 feet. Now we'll finish up with some special right triangles. And these special ones have patterns that we'll find out. So let's say we'll apply the Pythagorean theorem with these as we go through it to find the different side lengths. And this will help us as we start to find patterns. We can solve them a little bit quicker. So the 45, 45, 90 triangle, called that because it has two 45-degree angles and a 90-degree angle. Pretty clever. So in this one, we'll find the hypotenuse is square root of 2 times as long as each leg always. So we'll take a look at how that works, but you'll find this is a pretty cool pattern that we work with. So in this right triangle, I have 45 degrees 90, which would make this 45 degrees as well. Since the two angles are the same, we know that the opposite two sides will be the same, because we learned that with the base angles of an isosceles triangle. So this will also be 8. So in order to find this side, well, if we wanted to use Pythagorean theorem, 8 squared plus 8 squared is c squared. C is always the hypotenuse, so 64 plus 64 is c squared. And hopefully we'll see that pattern result that it is a square root of 2 times bigger. So it equals 128. Take the square root of 128 to get c. If we simplify this down into simplest radical form, trying to find numbers that we can divide out, well, 128 can be divided by 4. When I divide it by 4, 128 divided by 4 is 32. So square root of 4 times square root of 32. I can see that there are more perfect squares I can pull out of there. Square root of 4 is 2. Square root of 32 I know is 16 times 2. So square root of 16 times square root of 2. Square root of 16 I know is 4, so 2 times 4 times square root of 2 is c. 2 times 4 is 8 times the square root of 2. So we see that pattern resulting that the legs times square root of 2 gives us the hypotenuse in 45, 45, 90. Why don't you try B there and see if you can get the same pattern. So since the two sides are the same, we've got an isosceles triangle, which means the two angles are the same, 90, so we only have 90 degrees left, so these are both 45. So it's a 45, 45, 90 triangle. Here's the hypotenuse, call that c, so 3 squared root of 2 squared plus 3 squared root of 2 squared equals c squared. 3 times the square root of 2 times itself, 3 times 3 is 9. Square root of 2 times itself is 2, so 9 times 2 is 18. So we have 18 plus 18 equals c squared. That combines to give us 36. Take the square root of that, and that gives us 6. And we would get the same thing if we took that leg, 3 square root of 2, multiplied it by the square root of 2. Square root of 2 times square root of 2 is 2. So 3 times 2 gives us 6. So if you can start to see those patterns, then we can save ourselves a little bit of time. We wouldn't have to use the Pythagorean theorem. Let's take a look at the example on the bottom of the page. Here we know the hypotenuse, and we know the two side lengths are the same. You know, if two side lengths are the same, we've got two congruent angles, which happen to be 45 degrees. So let's see what happens when we try to find the two lengths of the legs. So x and x are the a and b. So x squared plus x squared equals 5 square root of 2 is the hypotenuse. And what happens then if we simplify? We got 2x squared on the left side of the equation. The right side, 5 times square root of 2 gives us 25 times 2, which is 50. Divide both sides by 2, you get 25, and then take the square root. X will be 5, which you can see there is that connection. 5 times the square root of 2 gives us our hypotenuse. And the final special triangle we'll take a look at is the 30, 60, 90. You can probably guess why it's called that. 30, 60, 90 degrees. Another way to think of it is, think of it as a equilateral triangle where we have 60 degrees and this angle split in half, so it's another 30. So we have three 60-degree angles. So remember, in a equilateral triangle, all the sides are the same. So if this one's 2x, this one would also be 2x, which would mean this would also be 2x, but since it's split in half, this side is only x. So in this case, for our 30, 60, 90, one of the legs is x, the hypotenuse is 2x. We find the pattern works that the longer leg will always be times the square root of 3 of the shorter leg. So 30, 60, 90, let's figure out the length of x. So let's make ourselves an equilateral triangle. So this is 60 degrees, and this angle is also 60. So all the sides are the same length. So if this is square root of 3, this is also square root of 3, which would mean square root of 3 plus square root of 3, this is 2 square roots of 3 for all the side lengths. So in order to find x, now I've got two sides in a right triangle, so I can find the Pythagorean theorem. So I've got a and b. Here's my hypotenuse. So square root of 3 squared plus x squared equals 2 square roots of 3 squared. Square root of 3 squared is 3 plus x squared equals 4 times 3, 12 is 2 square roots of 3 times itself. So I subtract 3 from both sides. X squared equals 9. Therefore, x equals square root of 9, which is 3. So we see that pattern resulting there. That square root of 3 times square root of 3 is 3. So the longer leg is square root of 3 times longer than the shorter leg. Number 6, they've drawn the equilateral triangle in and split it up. We're trying to find the altitude. So all the sides are length 4, but if we split it in half, now we've got 4, 2. How do we find h? A, b, and c. So 2 squared plus h squared equals 4 squared. So you've got 4 plus h squared equals 16. Subtract 4 from both sides, h squared equals 12. Square root, h equals square root of 12. So we can break into square root of 4 times square root of 3. And square root of 4 is 2. So we have 2 times the square root of 3. And we see that pattern resulting. Shorter leg times 2 gives us hypotenuse in the 30, 60, 90, and shorter leg times square root of 3 gives us the longer leg. So you get some practice with that in your assignment.